We want to use a 32-inch pump that operates at 1170 RPM to pump water at 60 degrees Fahrenheit from one reservoir to another that's 120 feet higher through 1,500 feet of 16-inch pipe that has a friction factor of 0.03. What would the system curve be for this graph? Just to let you know right now, this is a two-part question. The second example, we're going to match the system curve to the pump. So let's take a look at things right now. And so what do we need to do? We need to calculate out what our system curve is going to be. So the head of the system is going to be the height difference plus v squared over 2g times FL over D, sum of the minor k's. And we're eventually going to need this in the form of A plus CQ squared, where C is that constant of everything put together. So the first part is easy. A, static head loss. This guy right here, and the problem told us that's 120 feet. So the next thing that we need to do is we need to calculate out all of this. We need to plug all this stuff in. K is going to be 0 because that's given to us in the problem. Now we do have this part here. So if we look at this, let's so H system is 120 feet. That's our A plus V squared over 2G, where 2 is 9.81. 2G is 2 times 9.81 meters per second squared. And then we have FL over D. So F is given to us in the problem as 0.03, 1,500 feet of pipe length divided by 16-inch pipe. I'll just divide that by 12 right there to put that into feet. And so we can start jamming all of that together. But one other thing I want to do is I do want to change V, because I do want to get it into the form of Q. So how do we do that? Well, V is equal to Q divided by the area. So for V, I'm going to plug in Q over the area, which is pi over 4, 16 divided by 12 feet squared. So what I want to do now is I'm going to take this term, I'm going to plug that right in for the V, and then I'm going to bash everything together. Plug it all into my calculator, churn it out, and what I'm going to be left with is the H of my system is 120 feet plus 0.269 Q squared feet. Now, so that is an excellent system curve that gives it to us in gallons per minute. Problem is our graph uses thousands of gallons per minute. So how do we convert this over? Well, if Q is going to be in terms of terms of GPM, we just need to convert that over into thousands of GPM. And as I just said that didn't really seem right because I'm not thinking. If I look at my units here, my Q in this one is actually has to be in cubic feet per second. So what I need to do is I need to change Q over from cubic feet per second to thousands of GPM. So the way I'm going to do that is I will take Q, multiply it by 1,000 to get us into the thousands of gallons per minute. But then I have to do my conversion, and we've used this conversion forward, but now I'm just going to go backwards. So 1 GPM is going to be 0.00223 feet cubed per second. And so now if we multiply all that through, our system curve is going to be 120 feet plus, now all of this goes in here, gets squared, 1.335 Q squared. So this is our system curve. And we're using the same units as our pump curve to make it easier to match them up.